There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radium, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Pie Guy Pepin buys 5 pencils and 3 pens for $4.25. Chemical Charlie buys 8 pencils and 6 pens for $8. What is the cost for one pen and 1 pencil? Okay, so first we need to have this X. So we have to let X equal the cost of 1 pen. And then we get Y to equal the cost of 1 pencil. But we can't do X and Y with just one equation. So we have 2. 3X plus 5Y equals $4.25.
And that's from the first equation, the first bit of information. That's Pie Guy Pepin. He bought 5 pencils, and 3 pens for $4.25.
And Chemical Charlie bought 6X and 8Y for $8.
6 pens and 8 pencils for $8. So we have 2 equations with 2 unknowns.
Okay, so as you can see here, we have 2 times this whole first equation, Pie Guy Pepin.
All right, let's see. Click on it. All right.
Okay,
so we double the first equation so that we can cancel out the 6.
So now we have 6x minus 6x, which equals 0. 10y minus 8y, which equals 2y. And 8.5 minus 8, which equals 0.5. So y equals 25 cents.
And that's the cost of a pencil. Now let's go back up first.
Okay.
To get the cost of the pen, we're going to use the first equation here, 3x plus 5y. We can use the second.
But now that we have y, we can do 3x plus $1.25.
5 times 25.
Yeah, 5 times 25.
Equals.
And now 3x equals $3. So x equals $1.
Okay, so that's an example of a simultaneous equations. We have 2 pieces of information and 2 unknowns. And we eliminate one of the unknowns and solve for the other, and then we substitute and get the first one. Okay.
Well, it must be either out of charge or something.
Okay, another way to do this problem is to use graphing. All right, now let's take a look at the 2 equations. We have the first equation, 3x plus 5y equals 425. And if we solve that equation for y, we get this equation right here.
This equation right here.
And then the second equation is 6x plus 8y equals $8. And if we solve that equation, we get this here. So let's make the pen price. Each of these equations have an infinite number of solutions. But the thing is, they have to be solved together. And then there's only one unique solution, one unique value of x and y, one value for y. So let's have the pen price, which is x, go from 0 to 2.2. And let's solve for the pencil price in terms of x, and let's plot them. All right? So we have 2 equations. And the first equation, this is the equation 2. And this is equation 1. And you can see they cross. And where do they cross? They cross at 1. So the pen price must be $1. And the y value at 1 is 2.25. So this is another way of dealing with this problem. You can take the 2 equations and eliminate one of the variables like we did previously, or you can plot the two equations and get the crossing point, which is the unique solution which holds for both equations simultaneously. And that's why it's called a simultaneous equation. Okay, this is Chemical Charlie,
And this is Pie Guy Pepper.
and we'll see you
Sometime again.